So the goal then today is to calculate molecular formula. I'm just going to call it molecular formula like that from empirical formula. Remember, the empirical formula is the lowest ratio, and molecular formula is some multiple of that. To do that, you have to be given two things. You have to either be given or have found already the empirical formula. I'm going to tell you one right now. It's P2O5. How do I know that's an empirical formula? Yeah, you can't reduce it anymore, right? You can't reduce it anymore and maintain that ratio with whole numbers. And then you also have to be given another piece of information. You have to be given molar mass of the molecular formula. So those two things have to be given to you, or you can find the first one. So let's say the molar mass of this molecular formula is 284 grams per mole. Now, if you want to find the molecular formula given those two pieces of information, you have to do 3 steps. Are you ready for them? Yeah. I hope so. First one, determine the molar mass of the empirical formula. So that's this one right here. Either you found it or it was given to you, but you have to determine that molar mass. So you use your periodic table. Phosphorus is 31. There are 2 of them. Oxygen is 16, and there are 5 of them. And that ends up being 142 grams per mole. That's the first step. So far, so good. Nothing revolutionary. Step 2. Am I going too fast? Are we okay? Okay. Lee, your feedback is always much appreciated. Secondly, I'll use the words, but I'll give you the shorthand in a second, but you have to divide the molar mass of the molecular formula by the molar mass of the empirical formula. If that's too many m's for you, then really what you're doing is always dividing the big number by the small number. Or if you'd rather, no, just go with that. That's probably the safest bet. Big number divided by small number. The big number is always the one that's given to you. So that's 284 grams per mole here. And the small numbers usually are always the one that you found, which is 142. And you're going to get a whole number here every time. That whole number is what? At least in this case, it's 2. That is step 2. I know, right? Do you want to know what you do with that? You probably already know, right? Remember that the empirical formula, no, the molecular formula is just a multiple of this empirical formula. So now you take this 2, or whatever the number happens to be, and multiply your empirical formula by that. So multiply your empirical formula by your answer for number 2. From number 2. So that would look like this. You would take P2O5, that's the empirical formula, and you'd multiply it by 2. So instead of P2O5, it would become P4O10. And this is the molecular formula. Okay? So given empirical formula here and molar mass, you have to get both of those. To determine the molar mass of the determine the molecular formula, you have to follow those 3 steps. Pretty straightforward, right? Not a lot of really rocket sciencey math. What's more fun is when you start from scratch, from the percentages like we did yesterday, and go all the way to molecular formula. So we're going to try that now. Ready? So let's start with 2.46% hydrogen. 39.07% sulfur, and 58.47% oxygen. Oh, and you also have to be given the molar mass. So molar mass of the molecular formula is 246 grams per mole. And I want you to find molecular formula. Okay, so this starts off like yesterday. It gets you to here, and then you just follow the steps that I just showed you from yesterday. The first step is to change these percents to grams. That's easy enough. Second step is to do what? Good job, everyone. Convert to moles. So 1 mole, 1 gram for hydrogen. For sulfur, it's 32 grams. These are the numbers off the periodic table, of course. And for oxygen, it's 16 grams. You're so funny. Clearly, this will be 2.46. Now's the part where you shout out the other numbers. Carly, we're going to make it. I'm so happy right now. We're going to make it. Yeah. What's this one? 2, 3. We'll call it. And this one is what? What? Oh, yeah, 3.65. And then the last step, or the next step is to do what? Divide by the smallest of those 3 numbers, which is 1.23 or 1.22 probably, but who cares? And 1.23. And then usually you can be able to tell right here that you would have, this is about 2, this is going to be obviously 1, this is going to be about 3. And these are the coefficients for your empirical formula. So the empirical formula is going to be H2S, because there's one S, O3. That's cool. That's all yesterday's stuff. That's not what this question asked. It asked us to find the molecular formula. So now you go and do the stuff that the instructions I just showed you up top here. To find the molecular formula, the first thing you want to do is total the molar mass of this. Okay, so the numbers of the periodic table for this thing that you just found, the empirical formula. So hydrogen, there are 2 of them. Each one is worth 1, so that's 2. Sulfur is 32. Oxygen is 16 times 3. And that equals 70-something. I'm sure someone will tell me. Or we'll wait. You're 82. Fine. Then you take the bigger number, that's the one that's always given to you, and divide it by the smaller number is the one you just found. So 246 divided by 82. You should get a whole number right here. In this case, the whole number is 3. And the last step is to take your empirical formula we found right here and multiply it by this whole number. So instead of H2SO3, we're going to get times 3, H6S3O9er. And that is the molecular formula. Notice it's just a multiple of this empirical formula.